Hello everyone, my name is Devansh Singh and today I am going to present my internship project Food App, a full stack food ordering web application that I built during my 1 month internship with Webstack Academy. So let's move to slide 2 where before I dive into the project, let me briefly introduce myself. I am Devansh Singh, a student of BTech in Computer Science and Engineering at Babu Banarsi Das, Northern India Institute of Technology. This project was built as a part of a 1 month MERN web development internship with Webstack Academy, where I was trained in full stack web development using the MERN stack. During this internship, I gained hands on experience in React.js and Redux for building the front end, Node.js and Express.js for developing backend REST APIs, MongoDB with Mongoose for database management, JWT authentication for secure user login, Stripe for payment integration, Cloudinary for cloud based image storage. This wasn't just a learning course. I actually built a real working production ready application, and that is what I am going to present today. So let's move to slide 3. So what exactly is Food App? Food App is a full stack food ordering platform similar to Zomato or Swiggy but built completely from scratch using the MERN stack. The idea is simple. A user visits the website, browses different restaurants in their area, opens a restaurant's menu, selects food items, adds them to the cart and pays online all in one smooth experience. The six main features of Food App are: first, restaurant browsing. Users can search for restaurants by name and browse available options. Second, menu system. Every restaurant has its own menu with food images, descriptions, categories, and prices. Third, cart system. Users can add or remove items from the cart and quantities update in real time using Redux. Fourth, secure online payments. Stripe is integrated so users can pay safely and securely. Fifth, user authentication. Users can register and log in securely using JWT authentication. Sixth, order confirmation. After successful payment, users are redirected to an order confirmation page. This is a complete end to end application, not just a front end design. For further, move to slide 4, technology stack. Now let me explain the technologies used to build Food App. The project is based on the MERN stack, which includes MongoDB, Express.js, React.js, Node.js. So first we explain MongoDB, a NoSQL cloud database used to store users, restaurants, food items, and orders. Express.js, a backend framework used to create APIs and handle server side logic. Third one is React.js, the front-end library used to build the interactive user interface. Node.js, the JavaScript runtime used to execute backend code. Apart from the MERN stack, I also used Redux for state management, JWT for authentication, Stripe for payment processing, Cloudinary for cloud image storage. Each technology has its own responsibility, and together they make Food App a complete full stack web application. So let's move to our slide 5, system architecture. Now let's understand how all these technologies work together in Food App. The application is divided into 4 layers. layer 1, layer 2, layer 3 and layer 4. So layer 1, presentation layer. This is the front-end build using React.js. React Router manages page navigation, Redux manages the application state, and Vite provides fast development and build performance. Move to layer 2, API layer. Whenever a user performs an action such as logging in or adding food to the cart, the frontend sends an HTTP request to the Express.js backend through REST APIs. Layer 3, business logic layer. Node.js processes the request, JWT verifies user authentication, Stripe handles payments request, and Cloudinary manages images upload. Layer 4, data layer. Finally, all application data is stored in MongoDB using Mongoose models for users, restaurants, food items, and orders. This layered architecture makes the application clean, organized, scalable, and easy to maintain. Let's move to our slide 6, homepage screenshots. It's a homepage screenshot of my food app. At the top, we have the application logo, navigation menu, and the shopping cart icon. Below that is a search bar where users can search restaurants by their name. Further down, user can see a list of restaurants. Every restaurant card displays its image, name, cuisine type, and customer rating. The application has a modern, dark navbar and light theme, making it attractive and easy to use. This is not a static design, it is a real React.js application connected to a live backend and MongoDB database. So let's move to our slide 7, login and register. This is the login and registration page of food app. Users can create a new account or log in with an existing account. When a new user registers, the password is encrypted using bcrypt before being stored in MongoDB. When the users log in, the backend verifies the credentials and generates a JWT token which is stored as a secure HTTP only cookie. This ensures that user session remains secure and protected from unauthorized action. It also have protected root guards, auto session restore, cookie based sessions, JWT token on success, email plus password fields, login and registration tabs. So let's move to our slide 8, cart and checkout section. This is the cart page of a food app. Users can view all the selected food items, increase or decrease their quantity, remove unwanted items, and view the total bill in real time. The complete cart is managed using Redux, which updates the UI instantly without refreshing the page. When the user clicks the checkout button, they are redirected to Stripe's secure payment gateway. After successful payment, the order information is saved into MongoDB and the user is redirected to the order confirmation. But before going to checkout, they will log in to their account. Let's move to our slide 9, backend REST API. Now let me explain the backend API of food app. The frontend communicates with backend using REST API. Some important API endpoints are: first one, get API v1 eats store, fetch all restaurants. Second one, fetch the menu of selected restaurants. Third one, fetch all the food items. Now some post commands. First one, register a new user. Second one, authenticate a user and generate a JWT token. Third one, add food items to the cart. Fourth one, place a new order. Fifth one, create a Stripe payment session. All APIs include proper error handling and secure authentication before processing user request. Let's move to our slide 10, JWT authentication flow. Now let me explain how authentication works in food app. Step 1. The user register by entering their name, email and password. Step 2. Before storing the password, it is encrypted using bcrypt hashing. Step 3. User logs in. During login, the backend verifies the password and generates a JSON Web Token JWT. Step 4. Protected routes. The JWT is stored inside a secure HTTP only cookie, making it inaccessible through JavaScript and protecting it from security attacks. Step 5. Whenever the user accesses protected page, the backend verifies the JWT before allowing access. Step 6. Even after refreshing the website, the user remains logged in because the frontend restores the session automatically using the stored JWT. The authentication mechanism provides a secure and reliable login experience for users. Now move to our slide 11, database design. Now let's understand how the data is stored in food app. I designed 4 main database models using MongoDB and Mongoose. User model stores the user's name, email, encrypted password, role and account creation date. Restaurant model stores restaurant details such as name, address, cuisine, ratings and image URL. Third, food item model stores the food name, description, price, category, image and the restaurant it belongs to. Order model stores the user's order details, selected food items, total amount payment, status and Stripe payment ID. MongoDB is a flexible NoSQL database, making it easy to manage large amounts of application data efficiently. Now move to our slide 12, challenges and solutions. What challenges I have faced and how I gone through it. So every project comes with challenges. While developing food app, I faced several real world problems. Challenge 1, course configuration. Initially, my front end and back end could not communicate because of course restrictions. I solved this by configuring express course middleware and allowing trusted origins. Challenge 2, user session persistence. After refreshing the page, users were getting logged out. I solved this by restoring the user session using JWT authentication whenever the application loads. Challenge 3, Stripe integration. Understanding payment session and payment confirmation took time. After studying Stripe documentation, I successfully integrated secure online payments. Challenge 4, image upload. Uploading restaurant and food images was another challenge. I solved it using Cloudinary, which stores images in the cloud and returns image URL to my application. These challenges improved my problem solving skills, and gave me practical experience in full stack development. Let's move to our slide 13, key learnings. This internship helped me gain valuable practical experience. I learned how to connect a React frontend with a Node.js and Express backend. I understood the importance of secure authentication using JWT and bcrypt. I learned how online payment gateways like Stripe work. I gained experience with cloud services like Cloudinary. I also learned Redux for efficient state management. Most importantly, I learned how to build and complete a real world full stack project within a limited time. This internship significantly improved both my technical knowledge and my confidence as a developer. So these are 6 key learnings from internship. So move to our slides 14, future enhancement. Although food app is fully functional, many exciting features can still be added. Some future improvements includes mobile application using React Native, real-time order tracking using Google Maps, AI-based food recommendations, restaurant admin dashboard, customer reviews and ratings, multi-language support including Hindi. These features can make food app even more user-friendly and powerful. So let's move to our slide 15, which is thank you. Finally, I would like to thank Webstack Academy for providing this internship opportunity and my mentors for their continuous guidance. So thank you everyone. Now move to our live preview of my website. So let me open it. If you have any questions, comment out. Let me open it. So this is my navbar and it have a logo, and then we have a search bar, and then we have a listed 8 restaurants in it, in which we can categorize it by pure veg. The one who don't want to eat non-veg, they can categorize by a pure veg section or sort by reviews and ratings. So, and it also have a cart section. If we open one restaurant, it shows dahi papdi chart and whatever. Then you have to add to cart, then you have to go to cart, and you have to plus, minus or delete the item if you don't want it. And before proceeding to checkout, you have to log in first. If you don't log in it, you never proceed to the checkout options. So first, if you have an existing account, you have to log in, otherwise you have to register. So after that, the order will be placed. And if you want to sort it by a ratings, you can, and for reviews you also can. And move to our database. Now I will show you my database, which is MongoDB, which I used for this project, and I will show you I connected and my login part of my MongoDB. Let me open it. So this is the MongoDB interface, and we have data sections, and here is the my cluster, which is cluster 0, and we make an and we did it a name, food app. Now let me show my code section to you. This is an env file, which is a very important file in a folder. We placed it in a backend, and here we hide all our keys or API keys, MongoDB keys. To connect MongoDB, we put it here in env file, and you don't have to show this file to anyone. If you show this file to anyone, they can leak your data or use your API keys without your permissions, and you have to face some consequences if you show or give your env file to anyone. So this is my all project. Thank you for watching.